We're going to look at momentum diagrams and how they can help us see how momentum changes when an impulse is added. So we start with an initial velocity versus mass diagram or mass graph, and that gives us the initial momentum. So we have velocity versus mass, and that gives us momentum. So the area of this graph gives us momentum inside here. Then we add to that a force versus time graph, which represents impulse, which is what we looked at in the last lesson. So we have some impulse added to it. And together, so we add those together, and that gives us the final momentum of the system. So add these two together. I'm just approximating here. I'm not really adding them together. And that gives us our final momentum. Let's see, it's right here. So we have our velocity times our mass, and that gives us the final momentum. So these diagrams are really helpful to give a sort of visual idea about the momentum changes. So we start with our initial momentum, we apply an impulse, and then that ends up with the final momentum. So it's just a good visual idea about what's going on with momentum changes. All right, so let's look at an example here where we actually have all of the numbers correct. So we have a small box with a mass of 3 kilograms. It's moving across a frictionless surface with an initial velocity of 4 meters per second. The box is pushed for 3 seconds with a force of 2 newtons. And then we want to know what is the final momentum of the cart. Okay, so if we look at our first panel here in the graph, we have velocity, our initial velocity, and we have mass. So our mass is 3 kilograms. So our graph on the x-axis is mass. So we go over three blocks, and we have an initial velocity of 4 meters per second. So we go up 4 here. So that would give us a momentum of 12 kilogram meters per second. So the area of this graph, 4 times 3, takes up 12 blocks on the graph. So that's our initial momentum. Then we're going to add our impulse. So we have a force of 2 newtons for 3 seconds. So here's our 2 Newton force for 3 seconds. So the area of this graph, if we remember a force versus time graph, gives us our impulse. So now we're going to add these two together. So we have another velocity versus time, or velocity versus mass graph here. So this is our final momentum. The mass doesn't change. So we have 3 kilograms. If we add 12 plus 6, that gives us 18. So we know if we have 3 kilograms, then we have to go up to 6 meters per second on the final velocity. So this area here is our final momentum. So we have a final momentum of 18 kilogram meters per second. And we have a final velocity of 6 meters per second. So by exerting a force of 2 newtons for 3 seconds on the initial car, or the box moving at 4 meters per second, we end up with a velocity of 6 meters per second with our mass of 3 kilograms. Okay, let's try another example here. So we have a dynamics cart with a mass of 1 kilogram, is rolling on a frictionless track with an initial velocity of 4 meters per second. The cart is pushed in the opposite direction of its motion with a force of 5 newtons for 2.0 seconds, and we want to know the cart's final momentum. Okay, so we've got 1 kilogram for 4 meters per second. So let's do each hash mark as a half a kilogram. So, and we have 1, 2, 3, 4. Okay, so we go 4 meters per second. And that's 1 kilogram. Okay, so that is our initial momentum. So that gives us an initial momentum of 4 kilogram meters per second. Then we have 5 newtons for 2 seconds. Okay, so, and it's a negative, so it's the opposite direction. So we're going to do a negative 5 newtons for 2 seconds. So we're going to do a half a second, 1 second, half a second, 1.5 seconds, 2 seconds, and then we're going to go down 5 newtons. So that's 1, 2, 3, 4, 5. Okay, so we go over 5, and that's 2. So this is 2 seconds, and this is 5 newtons. Okay, so that's 10 newton seconds, or minus 10 newton seconds, which is equal to minus 10 kilogram meters per second. Okay, so we started with 4 kilogram meters per second. We added minus 10 kilogram meters per second. So if we have the same mass here, so it's going to be 1 kilogram. So our final momentum is going to be we started with minus 6 kilogram meters per second. So we have 1 kilogram here. So we got to go down to 6 meters per second. 1, 2, 3, 4, 5, 6. So this is 1 kilogram, and this is 6 meters per second. So our final momentum is minus 6 kilogram meters per second. So here we can see drawn out for us our initial momentum of 4 kilogram meters per second, our impulse being applied, which is minus 10 kilogram meters per second, and then our final momentum, which is minus 6 kilogram meters per second.